we will learn how to integrate using trig substitution. Let's say you're given the square root of a squared minus x squared. You must know this. You will substitute x will be equals to a sine theta, form 1. Number 2, if you've given this form, the square root of a squared plus x squared, x will be equals to a tan theta. Number 3, if you have given the square root of x squared minus a squared, x must be equals to a sec theta. So this is what you're supposed to know. We'll use this on the later stage. Alright, let us apply this. Let's say now you have given the integral. Let's say now you're given the integral. How can you solve this? The integral dx over x squared into multiplied by the square root of 4 minus x squared. We've given this integral. So as you can see here, which one you will apply here? We'll apply this one. We know that we'll have this format. If you can check here, we have the format of the sign, right? We have this one, the square root of a squared minus x squared. We know that, checking here, a will be equals to 4, a squared will be equals to 4, then a will be equals to 2. X is equals to a sine theta, therefore x will be equals to what? A is 2 sine theta. So we'll substitute now. So we'll have, supposed to substitute dx, right? So let us take the dx between. In this we can differentiate this one. Dx must be equals to what? 2 cos theta multiplied by d theta. Then we can substitute this to the original integral. This integral dx will be equals to 2 cos theta minus, we have x is equals to, put the parentheses, will be 2 sine theta raised to the power of 2. We'll have here the square root of 4. What is x? We still have this guy there. We'll have minus 2 sine theta raised to the power of 2. Alright, so still have the integral of 2 cos theta d theta all over, that will be 4 sine squared theta into square root of 4 minus u square, there will have 4, u square sine would be like that. This is what we have. So we have the integral of 2 cos theta d theta all over 4 sine squared theta. So here we have the common factor, which is what? It's 4. We have the common factor, which is 4. We'll take out 4 as a common factor. We'll have, if we take out 4 as a common factor, there we'll have the square root. Take out 4 as a common factor. The square root of 4, 1 minus sine squared theta. Integral of 2 cos theta d theta divided by 4 sine squared theta. This is the same as what we're applying our trig ratios. We know that will be cos squared theta. So we'll have the square root of 4 cos squared theta. This will be integral of 2 cos theta d theta. Divide this by 4 sine squared theta. Then square root of 4 cos squared theta will be equals to, take the square root there of 2, we'll have 2. This will be what? Cos theta. They will multiply by 2 cos theta. Right, that is what we have. But here 2 cos theta and 2 cos theta will cancel. We'll simply left with, let's take 1 over 4 outside of the integral. This will be 1 over 4. Take 1 over 4 outside of the integral. We'll be left with 1 over sine squared theta d theta. Right, so this is an inverse. Will be have 1 over 4. That one will be what? Cosecant squared theta d theta. So this is what we have now. Then we still have what? The integral. We still have the integral like that. So 1 over 4, the integral of this guy will be negative cot, so I'll just put negative, would be minus 1 over 4 cot theta plus constant c. So this is what we have, but we are on, let us go to the u world, because here we're on the theta world. You can go to the u world. Initially we said that x is equals to sine, we said is equals to, initial we said is equals to 2 sine theta. So making the subject there, we'll have divide by 2 both sides. We'll have x is equals to 2 must be equals to sine theta. So forming a triangle, this will be opposite, it's x, hypotenuse there is 2. We have our theta here. Then take the Pythagoras theorem. We'll have the square root of 4 minus x squared. Alright, so this is what we have. But what is cot? We want to substitute cot. Cot theta will be same as what? Square root of 4 minus x squared divided by x. So this will be equals to minus 1 over 4 square root of 4 minus x squared divided by x plus constant c. So this is what we have for this particular equation. So let's say now we are given again the integral of root x squared minus 25 over x dx. We're supposed to see that the radical then will use that, we know that the square root, using the fact that the square root of x squared minus a squared must be equals to a sec theta, using that fact. So a there is 25a squared would be what? 25a will be 5. Taking the square root both sides, we'll have 5. Alright, we'll have that. This is what it's x x must be equals to a sec theta. Alright, so this is what we have. Then therefore x will be equals to 5 secant theta. So we can substitute into an integral. We'll have the square root. What is x? Here it's x. We'll have 5 sec theta squared minus 25 all over x, which is 5 sec theta multiplied by, we're supposed to have dx, so just take dx here. Dx will be equals to what? We'll have 5 secant theta multiplied by tan theta. So we'll substitute this by 5 sec theta multiplied by tan theta d theta. So that is what we'll have. So the integral square 5 will have the square root. 5 will have 25 secant squared theta minus 25 all over 5 secant theta multiplied by 5 secant theta multiplied by tan theta d theta. The integral of, let's take out the common factor there of 25. We'll have the root 25 secant squared theta minus we'll have the minus 1 all over 5 secant theta multiplied by 5 secant theta tan theta d theta. So we know that secant squared theta minus 1 must be equals to what? To tan squared theta. Using this trigonometrical identity, we'll substitute that. So there we'll have the integral of root 25, substitute this by tan squared theta all over 5 sec theta multiplied by 5 secant theta multiplied by tan theta. This will be the integral. The root of 5 of 25 will be 5 tan theta. This and this will cancel them. We'll have over 5 secant theta multiplied by 5 sec theta multiplied by tan theta, tangent theta there. All right. So these two guys, this and this will cancel. We'll be left with this. Let's take 5 outside of the integral. We'll have 5 integral multiply tan and tan. We'll have tan squared theta d theta. So this will be equal. Can expand these using the trigonometrical identity. We'll have 5. This will be secant squared theta minus 1. Alright, so this is what we have so far. We have our integral then. So 5, the integral of sec theta will be tan theta minus the integral of 1 will be theta plus some constant c. Right, that is what we have. So this is in the what? Yeah, we're in the theta world. We must go to the x world. Initially, we know that we have set x must be equals to 5 secant theta, sec theta. Then we can have sec theta will be x over 5. So if we have our diagram, triangle, we'll have theta. Here opposite will be x, adjacent is 5, hypotenuse is x, adjacent is 5. This will be the square root. Pythagoras will have x squared minus 25. All right. So here we'll have what? This will be equals to, we have 5 tan. What is tan? Tan will simply equals to opposite of adjacent. Tan will be equals to root over if given there will be root over what? 5. We have minus now theta. So here we can find theta. Theta will simply equals to x over 5. You take the inversely there, theta will be sec x over 5 plus some constant c. So all this must be multiplied by 5. 5 and 5 will cancel. So in the end, we'll obtain these to be root x squared minus 25 okay over 1. So is nothing there. I don't supposed to write that. So here there minus 5 plus some constant c. So